This doesn't look that bad.
Nope.
Okay.
Properties of the definite integral. So when we talk definite integral, remember those are integrals that have the boundaries. They have the a and the b, okay? Or whatever values, but they have values. Whereas indefinite integral, it doesn't have the boundaries, so we always say plus c. Now, these are just properties, things that can be done. Some of them are more obvious, I kind of want to say common sense in a way. They just make sense, like this first one. Some are a little bit less obvious. So what this first one is saying, the integral from a to b of f of x plus g of x can be broken up into two integrals. So if you have terms added within an integral, it can be broken up into multiple integrals if necessary. Okay, so the integral from a to b of f of x plus the integral from a to b of g of x. The second one you are already quite familiar with. If k is a constant, that k can be pulled out front as a factor. So the integral from a to b of k times some function f of x, you can pull that factor out front, and it's k times the integral from a to b of f of x. So that's one that we've talked about previously.
I was going to say, a lot of these seem at least a little.
Exactly. They're either familiar or, I don't know, I hate to say common sense, but they make sense. That's what I should maybe say. Some people complain, don't say common sense. I don't have common sense. Okay.
A lot of people.
Yeah. Okay. This third one. This one's probably new. I don't think we've talked about this one, but it can be very helpful at times. The integral from a to b of f of x is equivalent to the opposite, or the negative integral from b to a of f of x. So if you have a reason, and you will have reasons at times, where you need your boundaries to switch, okay, what's on top versus what's on bottom, we can do that by just multiplying the integral by a negative, okay? So that's one we'll talk about. This next one's very helpful. The integral from a to b of f of x plus the integral from b to c of f of x is equal to the integral from a to c of f of x. Notice it's f of x all the way across, so it's the same function. The boundaries were a to b and then b to c. In the end, it's a to c. So if the upper boundary on one integral overlaps with the lower boundary on the other integral, you can take those other two boundaries and make it just one integral. And there are times, especially as we get ready to talk about finding the area between two curves and whatnot, where we need to break integrals up, and that's helpful to know. Next one, the integral from a to a is always equal to 0. Because remember, when we plug in, you do the upper boundary minus the lower boundary, you're going to be subtracting itself, and so when the boundaries are the same, that integral is always equal to 0, no matter what. Okay, what's our next one? If our function is positive on the interval from a to b, then the integral from a to b of that function must be positive. Okay, so if the function is positive, then basically the integral must be positive. If your function equals 0, then your integral must equal 0. And if your function is less than 0, which basically says negative, if your function is less than 0 or negative, then your integral is negative. Let's see. If g of x is less than f of x, so if one function is less than the other, then the same is true on their integrals. Again, assuming we're on the same boundary, right? So if g is less than f, then the integral of g is less than the integral of f. If f equals g, then the integral of f equals the integral of g. So again, some basics there. All just integral rules to just be familiar with. We're going to use several of these today to, demonstrate some of the pieces. And in fact, I have this moved up a little bit. Example 1 right here is at the bottom of the page. So, sit there and look at that. And try and see what connections you can make. The integral from -1 to 1 of f of x equals 7. The integral from 1 to 4 of f of x equals 2. We want to evaluate what is the integral from -1 to 4 of f of x equal. And the catch here is, do we know what f of x is? We don't know what this function is, so we can't actually do the integration. We have to go by our rules here. Ethan? And why can we just add them together? Okay, we have the same b value. So this is going right back up. I specifically made sure that this one was available. Okay, it's going back up to that one where the integral from a to b plus the integral from b to c equals the integral from a to c. And so what we can look at here, which way do I want to? The integral from -1 to 1 of f of x dx plus the integral from 1 to 4 of f of x dx is going to equal the integral from -1 to 4 of f of x dx. And I like how Ethan put it. He said because we have the same b value, right? And so because that b value matches, we can make this the integral from -1 to 4, which is what they want us to find, isn't it? And what do we know about the two givens? The integral from -1 to 1 is 7. The integral from 1 to 4 was 2. And we're smart cookies that know 7 plus 2 is 9. So just watch for those. They tend to like to put those boundaries the same. Okay, ready for the next page? Got through the first page really quickly. Let f and g be functions such that the integral from of f from 1 to 3 equals 4, and the integral of g from 1 to 3 equals -1. Evaluate. The integral from 1 to 3 of 3 times f of x minus 1/3 times g of x d of x. I'm going to kind of draw this out more than you guys want me to when I write it out, just saying, because I know you guys are just going to jump right to the end, and that's fine. But let's talk about the different pieces that happen here. So what do you see, Ross?
I was going to say it's multiplying the integral of f of x on those parameters by 3, and then subtracting 1/3 of the integral of g of x. So couldn't we pull those two out, which would cancel, because it's a 3 and a 1/3, right?
They're not going. We're subtracting those pieces though. And again, there's a couple different ways we can write out. I'm going to write out a little bit more than what we need to, but one thing I see here is within this integral there's subtraction happening, yes? So officially that means I can rewrite this as, instead of just one integral, I can rewrite it as 2 integrals being subtracted, and that was one of, is that like maybe our top rule there, except it was adding, but adding, subtracting, same difference. So one thing I can do is I can say, okay, the integral from 1 to 3 of 3 f of x dx, and then minus the integral from 1 to 3 of 1/3 g of x dx. So that's one of my properties right there that I wanted to demonstrate, is I had adding, subtracting within there, so I can break it up into 2 separate integrals being subtracted.
And then now that they're separate, we can take those coefficients out.
Yeah. Then the other piece is we have these factors right here, right? These coefficients or scalars, which that's one of those rules we've already talked about prior to today, but those can be pulled out front. And again, I don't know, do you have to write it all out like this to understand it or to do it? No. But I think it just helps to show it and help you understand the rules. So this is 3 times the integral from 1 to 3 of f of x dx minus 1/3 times the integral from 1 to 3 of g of x dx. Now, do you see all the pieces? We have a 3 here, right, which is 3. What do we know about the integral from 1 to 3 of f of x dx? It's 4. So that's going to be 3 times 4. Minus, we have a 1/3. And what do we know about the integral from 1 to 3 of g of x? -1. So that's the math you're doing. Whether you saw that math right off the bat or not, you know, you could definitely see that math without even rewriting anything. I'm not going to argue that fact by any means. So let's see. 3 times 4 is 12. 1/3 times 1 is 1/3. I would say a minus times a negative makes it a plus. So 12 plus 1/3 is 12 and 1/3. If you go back to Algebra 2, Math Excel would want it improper. They wouldn't leave it as a mixed number.
It's like 37.
And it would become 37/3. At the calc level, just some form, you know. Realize if this is a multiple choice problem, they might give you 12 1/3, they might give you 37/3. You look for what's, you know, equivalent to whatever you find. Are we okay with that? I don't think it's hard. I really, you know, not something like that. We do a lot harder stuff in here, don't we? Okay, let's try example 3. Suppose the integral from -2 to 1 of f of x is 3. The integral from 3 to 1 of f of x is 7. And we want the integral from -2 to 3 of f of x to be found.
I got an idea.
Go for it.
Okay, so you said that you can flip the boundaries and then make it negative, and if we do that, then we can do the other thing.
I understand what he's saying. Do you guys understand what he's saying?
He's saying because if we flip the second one, then they'd have the same value as that one, and then we can put them together.
Okay. It may not make sense if you don't understand where we're going with this, but I see it. Okay, so the key to realize is we have matching boundaries there, right? But we can't put these together because they're both top boundaries. We need it to be a top boundary and a bottom boundary for this to work. So how do we switch those two boundaries? Negative. And so I'm going to say I'm using this second one. And I'm using this second one because look at the goal. The goal is to have -2 to 3. We already have -2 on bottom. We need this 3 to top. So it's going to be the negative of the integral from 1 to 3 of f of x dx. Okay? So that's what's equivalent there. And now, if we think about this, this is the integral from -2 to 1 of f of x. And then we're going to say plus, except what we're adding is really a negative integral from 1 to 3 of f of x dx. And ultimately, when we do that, that's going to equal my b's match now, right? So the integral from -2 to 3 of f of x dx. Okay, that's the official lingo, writing it out. Mathematically, what do we know here? Integral from -2 to 1 was 3 plus the negative of the integral from 1 to 3, so -7. And 3 plus -7 is? -4.
And on these ones, do we have to put like the units squared or no?
No. Just numerical values here. Okay, we got it? You seem to also have seen that one relatively easy. Okay, let's go one more.
Now this is where it gets bad. Because they went ahead and wrote words.
They threw words in here. How dare they throw words into calculus?
No.
Okay. Assume F. See, that's the thing. They do know better. They know that you've made it to calculus. If you're smart, you can actually read and understand and comprehend, so they're going to make you use those skills. Okay. Assume F is a positive valued continuous function over the interval 5 to 8. Assume also that the absolute maximum of F over the interval is 12. So in that interval from 5 to 8, the maximum value is 12. That's the highest that function will ever go. The absolute minimum over that interval is 3. So that's the lowest it will go between 5 and 8. Use the properties of this lesson. State the maximum and minimum values for the integral from 5 to 8. Okay. Now I've got to make sense of this for you, right? Keep in mind we're looking for maximum and minimum values. I am going to kind of sketch a graph that we can refer to here. Because we want the area, or the integral, from 5 to 8. What does integral mean?
The area under that curve from 5 to 8.
Okay, the area under the curve from 5 to 8. The key is we don't know what this curve looks like, do we? Other than we know it has a maximum value of 12 and a minimum value of 3. So I'm going to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 3, 4, 5, 6, 7, 8, 9, 10. Did not set that up right, but that's all right. You guys get the picture. Okay, so my x-axis, I'm trying to show 5 and 8. My y-axis, I'm trying to show the minimum value of 3, the maximum value of 12. Keep in mind, we are only looking between 5 and 8, right? We don't care outside of 5 to 8 what happens. And that's because the integral we're asked to find, or we're asked to talk about, is the integral from 5 to 8. We know, okay, we know there's a minimum value of 3. So between 5 and 8, I know my graph never goes below that minimum value right there. And I know there's a maximum value at 12. So I know my graph never goes above that. Again, we don't know what that graph looks like, do we? And so if I just randomly draw something, and I'm just going to draw a curve in here that all I care about, that's my curve. All I really care about is what's happening with that curve, though, between 5 and 8. Okay? And officially, we want the area under the curve, right? So area under the curve, well, if we go with this purple curve I drew here, area under the curve is, we're talking We're talking all that stuff right there, yes? We want to know a maximum value of that area, and we want to know a minimum possible value of that area. Okay. If we look based on our minimum value first, okay? How do I do that? Sure. If we look based on our minimum value right here, our minimum value is right there. If we're trying to find the area under the curve from that point, what area are we looking at there? I'm not sure if I'm saying that right.
Are you asking for the shape of the area?
Well, yeah, if we just go, okay, so, and again, is this definitely what the curve looks like? No, this is just, I drew a curve in here. But minimum area is, we know at some point there's a minimum value of 3. Maybe the whole thing has that minimum value of 3. We don't know, okay? And so with that in mind, if we're just trying to find the area at that point, at that minimum value point, what is the area under the curve at that point? So what do you see right here?
A rectangle.
A rectangle? Of what dimensions?
3 by 3. So
3 by 3? Because there's 3, from 5 to 8 is 3, yes. And then from 0 up to 3 is 3. So 3 times 3 is 9. So that rectangle, or square technically, that is our minimum possible value. So the idea there that our minimum possible value, the minimum value is 3, the interval has a width of 3, and 3 times 3 is 9. Thoughts on the maximum possible value?
it would be
The interval is still 3 wide, yes?
yes.
And if this curve goes all the way up to 12, pretty much all the way across, that max value is 12. And so 3 times 12, which is 36. That is my max possible value. And as I said, you're seeing the shortcuts in the fact that, oh, they gave me a minimum value on an interval 3 wide. So 3 times 3, 9. Obviously, that's a minimum possible value. Is it probably going to be a little more above that? Yeah, because unless this is just a solid line there that goes straight across that 3, it's going to be a little bit more above this, but this is a minimum possible value. Is it going to be all the way up to 36? Probably not, unless the curve is just a solid line going above that. But then based on the fact that they gave me a minimum and a maximum value, that's why it's probably not as low as 9 and it's probably not as high as 36, but we just, those are the extremes is what I'm showing here. Okay? And so they asked us to state the maximum and minimum possible values. If I want to get mathematical here, the integral from 5 to 8 of f of x dx is less than or equal to, wrong number, 36, or greater than or equal to 9, as in it is between 9 and 36. Does that statement make sense? a fancy way to show that the value of that integral is somewhere between the minimum of 9 and the maximum of 36. Okay.